Hello everyone, welcome to the channel HMPIONS. I am Abhishek sir and today we will study a very important topic of physics which comes in class 10 science, that is light reflection and refraction. Note that it is the part 1 of the whole video. In part 1 we are only going to study all things about reflection. Topics to be covered in this video is introduction, what is light, basic information about light, reflection, types of reflection we will see, reflection by plane mirror, spherical mirrors. We will also study a very important topic, that is ray diagrams, and then we'll finally end up this with mirror formula and magnification. Moving on to the introduction part. What is light? Friends, the variety of objects in the world around us are visible due to the light entering into our eyes after its reflection from the object. You see, from previous standards, we are studying about light, and the very basic definition that we can make out of that knowledge is light is a form of energy that enables us to see. Now, as we are in standard 10, we'll have another technical definition, that is, light is an electromagnetic radiation which produces sensation in our eyes. Now, various properties related to light, first of all, it is the fastest moving thing in the universe. The speed is about 3 into 10 raised to 8 meter per second. Imagine the fastest thing in the universe. Well, light always travel in straight lines. Lights are non-mechanical waves. What do you mean by non-mechanical waves? They do not require any medium to travel. Now, whenever we represent light in form of diagram, we use two things, that is ray and beam. Now, what is ray? Ray is a straight line drawn in the direction of propagation of light. And what is beam? Beam is nothing but a bundle of few parallel light rays. Now, friends, moving on to the next diagram. In this diagram, you can see a plane mirror and few lines and rays. Now, this diagram is representing a very important phenomena of light, and that is reflection of light. What is reflection of light? It is the phenomena of bouncing back of light rays in the same medium on striking a smooth surface. Right now in this figure, what is the smooth surface? It is the plane mirror. Now, bouncing back is a very important part of this definition, right? It is returning of light when it strikes any medium. That medium or that object must be plain, smooth, or polished. That is why we tend to polish the mirrors. Now, very important, if we want to study this figure, we need to know about the incident ray, the reflected ray, the normal. You see that red line in the figure exactly in between, which is perpendicular. It is called normal. Two angles we are going to study, that is angle of incidence and angle of reflection. Now, what is angle of incidence? In the figure you see there is an angle formed between the red line, that is normal, and the incident ray. That angle is called angle of incidence. On the other side you see again there is an angle between the red line, that is normal, and reflected ray. This angle is called angle of reflection. Now when light travels, and also about reflection, when reflection occurs, it occurs on the basis of few basic laws of nature. Those laws are called laws of reflection. Again, as we have already studied these laws of reflection in the lower standards, we'll be revising it very quickly. The first law is angle of incidence is always equal to angle of reflection. That certainly means that if the light ray is incidenting, suppose for example, if the light ray is incidenting at 50 degree from the normal, it will be emerging or it will be reflected at 50 degree only. That means the angle of incidence is always equal to angle of reflection. Moving on to the second law, It is very important when we are drawing the figure, the incident ray, the reflected ray, and the normal. These three things, the incident ray, reflected ray, and the normal at the point of incidence all lie in the same plane. Now, few extra points that I would like to tell you, which might not be included in our textbook, is that we'll study about image, what exactly is image, what are the types of image. Now, friends, if light rays coming from a point after reflection actually meet, or if they appear to meet at another point, then that second point is called the image of first point. There are two types of image which can be formed. First is real image, second is virtual image. Basically, they are bit different. Real image can be obtained on screen, virtual image cannot be obtained on screen. Likewise, we have many difference in this type of image which we already have studied in lower standards. That is why I am not going further into it. Friends, there are two type of reflection. The first is regular reflection, another is irregular reflection. Both these reflections they depend on the surface on which they strike. Likewise, if you see in the figure, the first is very polished, smooth surface. Uh, so the parallel rays after striking, they go back in parallel way. So that is regular reflection. In irregular reflection, you see the surface is not smooth, it is rough surface. So even if they are parallel, the incident ray are parallel, they are scattered and they are all going into different directions. Now, moving on to the reflection by a plane mirror. Plane mirror is the simplest type of mirror that is we are using. If the reflecting or the polished surface is plane, then that mirror formed is called plane mirror. So in this diagram, we are seeing how is the image formed in the plane mirror. Let us quickly go to the image properties. As you can see, the image formed is virtual and erect. Image cannot be obtained on screen. It is seen inside the mirror. It is erect. The size of the image is equal to the size of object. Also, the distance of image is equal to the distance of object. That means image distance is always equal to object distance. And next part is the last property is lateral inversion. Now quickly telling or revising about lateral inversion is when you are standing in front of plane mirror and when you raise your left hand, the image appears to raise the right hand. So there is a change in direction. So this type of image obtained by the plane mirror is called laterally inverted image, and this phenomena is called lateral inversion. Now another type of mirrors, they are called spherical mirrors. These are formed by cutting the circular cross section of spherical shell. Notice the word spherical shell. Uh, so cutting the circular cross section of spherical shell whose inner or outer curved surface are reflecting, we form spherical mirrors. Now, based on the figure, if you can see, the dotted lines indicate the hollow sphere. If the from the sphere we cut a part in which inner surface is reflecting, so that becomes concave mirror. And if the outer surface is reflecting, that is called convex. That means we have two types of spherical mirrors, one is concave and another is convex. Now let us understand few important definitions based on the spherical mirrors. The first two are center of curvature and radius of curvature. These are related with the spherical shell from which the mirrors are cut. The center of curvature is the center of that sphere of which the reflective surface forms a part. Radius of curvature is the radius of that sphere from which the reflective surface of the spherical mirrors are formed. Talking about pole, pole is the center of reflecting surface of a spherical mirror. Principal axis. Now, axis, you have already heard about axis when you have studied the Earth rotates on its axis. What is axis? Axis is an imaginary line which is passing through the center. Same way here we have principal axis, that is an imaginary line passing through pole and center of curvature of the mirror. Center of curvature of the mirror is denoted by capital C. Radius is denoted by capital R. Pole is denoted by capital P. Principal axis is a line, so we don't have to denote anything. Moving on to the next part, that is principal focus. The point on the principal axis where the rays are actually meeting after getting reflected. So if they are actually meeting, it is concave mirror. So that meeting point is called principal focus. While in case of convex mirror, they are not actually meeting, they will only appear to meet. So again, that point will become principal focus. Principal focus will be denoted by capital F. In some textbooks, we see small f as well. Next, it is focal length. It is the distance between pole and principal focus. And lastly, we have aperture. Aperture is the diameter of the reflecting surface. Moving on to the ray diagrams. But before we study ray diagrams, we have to understand few basic rules, right? And for these rules, we will take one or two light rays, and these two light rays, at least two light rays are enough for showing where the image is formed and how it is, right? So we will study four rules, out of which the first one is the rays coming parallel to principal axis will pass through the focus after reflection, or it appears to come from focus after reflection. Why there are two options? Because there are two kind of mirrors, so we are including both the mirrors in a single rule. Moving on to the next rule, that is the light rays coming through center of curvature or towards the center of curvature will reflect on the same path. They will come on the same path, go back to the same path. Next rule says the rays coming through the focus or coming towards focus, after reflection it becomes parallel, it goes parallel to the principal axis. The next rule is, and the last one, the rays which are coming obliquely to principal axis towards pole is reflected obliquely. And what do you mean by obliquely? At an angle, right? So if they are coming at an angle, they will go at the same angle after reflection. That is nothing but the first law of reflection, right? So these four basic rules will be necessary when we will study the ray diagrams. Why we are studying ray diagrams? Ray diagrams will give you the idea of image formation by these spherical mirrors. So moving on to the next topic, that is ray diagrams for concave mirror. We have totally 6 ray diagrams. Then we'll study ray diagrams of convex mirror, and here we have 2 diagrams. In ray diagrams, we will have to focus on 4 different things, that is position of object, where the object is kept, position of image, the nature and size of image. As it is a drawing portion, we will have to study the figure carefully, and then we'll have to write the position, nature and size. So quickly let us go. If the first one, if the object is at infinity, the light rays will come and they will meet at focus. So we can say that image is formed at focus. The nature is real and inverted, and size, as you can see from the figure, image is not clearly seen, so size of image is highly diminished. Second one, if the object is beyond C, the light rays are coming after reflection, they are meeting in between C and F. So we can say that image is formed between C and F. As light rays are actually meeting, it is real and inverted, and size is diminished. The next one is position of the object is exactly at C. So light rays are coming and meeting exactly just below the object at C. Real and inverted is the nature, and size from the figure we can guess that size is same as that of object. Moving on to the next part, if the object is kept between C and F, after getting reflected, the light rays are joining or meeting beyond C. They are real and inverted, and the size, if compared, now the image is magnified than the object. Moving on to the next one. If the object is kept between F and P, so what will happen? You see the light rays are coming but they are not meeting actually. So we have to elongate it on the back side. So that is why position of image is behind the mirror. The nature is virtual and erect, and the size you can see is magnified. The next and the last one for concave mirror is if we keep the object at F, the light rays which are going parallel will reflect parallel, and you see in the figure we cannot see whether they are meeting or not, so we'll assume that they might meet at any point in infinity. So they will meet, so real and inverted, but if they are meeting at infinity it will be highly magnified. So that's all for concave mirror. Now we are going for the next topic, that is ray diagram for convex mirror. We will study only two ray diagrams. First, the object is at infinity, so light rays will come. They will not meet actually, they will diverge away, but we have to elongate it, and we can say that it is behind the mirror and it is at focus. As we are elongating backside, so nature becomes virtual and erect, and size is highly diminished. The last figure is position of object between infinity and pole of the convex mirror. So position of the image will be behind the mirror between P and F. Nature will be virtual and erect, and size will be smaller than the object. Right? So we have finished the ray diagrams. You will have to draw it and you will have to study it very carefully. Moving on to the next topic, that is uses of concave mirrors. As you can see from the figures, concave mirrors are used as shaving mirrors, makeup mirrors. Dentists also use that, dentist mirrors. Then we will have torches and headlights of car. And lastly, concave mirrors are also used in solar furnaces. Next, use of convex mirror. They are used as rear view mirrors and traffic mirrors. Rear view mirrors has a very advantage that it enables the drivers to see the traffic behind. So that is how the driving becomes very safe. It gives erect but little bit diminished image so that we can have a wide field of view backside to avoid the accidents. Moving on to the next topic, that is sign convention. Friends, while dealing with the reflection of light by spherical mirrors, we shall follow a set of sign convention which are known as Cartesian sign convention. For that, we have to assume that the origin is at exactly at the pole. So any measurement above the pole, perpendicularly above is positive, perpendicularly below is negative. If you are moving to the right side of the pole, the values are positive, and then left is negative. So that we have to follow when we are solving numeric. Now, in mirror formula and magnification, that is our last topic. What is mirror formula? It is the formula which gives relation between three different things. The three things are object distance u, image distance v, and focal length f of any mirror. This relation, this formula is known as mirror formula. Now, lastly, what is magnification? Magnification is the relative extent to which the image of an object is magnified with respect to the object size. It can be expressed in two ways. The first is it is the ratio of image height to object height. Also, it may be the ratio of image distance to object distance. Magnification is shown by small m. So the formula becomes small m equals to h dash upon h equals to v by u. Notice that negative sign is according to the Cartesian sign convention. So that's all for reflection topic. We have studied all important topics related to reflection. So you have to stay updated yourself for the next video. So kindly like, share and subscribe to support us. Thank you.